I have two line segments on the board. We have your blue line segment and your red line segment. Let's just start off by listing what are some things you notice.
They intersect.
They intersect. Okay.
They have different colors.
They're different colors.
They're going in different
Dominic, what were you gonna say?
They are lines. I was gonna say each of them going to that one box. Yeah.
So
they intersect. Each of them are in the top box. Both.
In the coordinate.
Yeah.
All right. So they both eventually hit the first quadrant. Okay. Wyatt?
The blue one goes like
So, depending on whether you're looking at the y or the x, they're both in a little bit of the negative and the positive. They both have sort of a range of difference. Okay. What else? Anything? What was that? So our blue one has a positive slope to it, while our red one has a negative slope that's going down. Bradley, do you want to say that, please? A little bit more. Wyatt? So it's not a full line, it's a line segment. So they start at a point and end at a specific point as well. Any other thoughts? All right, boys, let's sit up, please. Thank you.
Distracted in class.
Actually, let's go back to your seat. This is my seat. You don't need to sit in the corner. Sit at the table, please.
I think you're better.
Sit, please make sure you're sitting at the table. All right. Let's change this question just a little bit. We noticed a lot of things. If you had to determine what was the range of x's for the blue line, what would you say is the range of x's? Or what is the range of x values? Wyatt?
-4 and 4.
So the range of x values, the lowest x value we go is -4. The highest x value is 6. So we could say -4 to 6, roughly. What about for the red values, or the red line? What would be your range of x values?
From left to right.
What are the numbers that are associated with that? What are the possible range of numbers that can fall?
-2, 5, or 5, -2.
So it goes from -2 to 2. We're just looking at the x. Right. So now let's think, what are the ranges of the y values for each of these? What's the range of my y values for my blue line segment?
-1 to 4.
So -1 to 4. This would be the range of my blue line. -1 to 4. And then the red one?
-1, or well, it'd be +5, negative.
So when thinking about a range, we typically start from, we go lowest to highest. So we'll start with
-1, 5.
-1, and we'll go up to 5 would be the highest value. Okay. So these ranges, these sort of intervals of x value, the lowest x value to highest x value, or lowest y value to highest x, or highest y value, we have a special name for this. We call these our domain and range of our functions. So the domain of a function is the set of all possible inputs of that function. So if you think about it, when you hear the word input, typically when we say the word input or output, we think of our sort of T table. We have our inputs on one side, and then we get an output for that value. For our functions, inputs have always been, or are typically, are x. So whatever you plug in for x, your output is whatever that answer comes out to. If I plug in 3 for x, I get 17 for my y as my solution. So that's your input and output. So the domain is the set of all possible inputs for that function. So what are all the possible values of x that you can place into this function? And that is called your domain. So if we think about it, our domain is the range, or our domain is what is the set of all of those possible x values we set. So any number between -4 to 6 would fall in the domain of this line segment. for the red one, it'd be -2. Any number between -2 to 2 falls within the range of that one, or the domain. The range is basically the same thing. It's just talking about the y values. What is for all the set of the set of all possible inputs or outputs of a function. So it's where all the possible y values for that function. And we have a special way. So this word set is a special word in mathematics. It means you have a special way of writing things. It's really important when you get on later on like calculus or even beyond that. The word set is an important word. For right now, we just have a special way of writing set. It's called set notations. We'll talk about that more tomorrow. The main thing we want to just focus on today is determining what is the domain and range of the function, and then we'll talk about how we can actually write those down in set notation tomorrow. But once again, domain is basically what's the range of x values. So what's your lowest x value that your function can ever reach? What's your largest x value your function can reach? Your range is what's the lowest y value your function can reach, and what's the highest y value your function can reach. From the smallest to the lowest, or smallest to the greatest, basically. Are we okay with this so far? So let's look at some examples and see if we can determine, okay, what is the domain and range of this function? So I have this green line segment here. I'm recording.
I don't pay attention.
So we have, what is the domain of this function? What is our domain of our graph? What? So the domain represents all of the possible values for the x's. So what's the lowest x value your graph reaches to what's the highest x value your graph reaches? So what's the lowest x value we reach? -1. So if we look, our farthest part to the left that the graph reaches is right here, which if we look at the x value is -1. What's the highest, or what's the most right, the largest x value we ever reach? What, action? 5. 5. We go all the way up to 5. So -1 to 5 is the domain. So -1 is the lowest, 5 is the highest. Same thing for the range. What is the lowest y value we ever hit on this graph, and what's the highest y value we ever hit on this graph? So 1's the lowest, okay, and then what is the highest? 7. Okay. And that would be your domain and range for the graph. So basically, it's just looking at the graph, looking, okay, where are my lowest parts, where's my leftmost part, where's my rightmost part, where's my top, and then determining where those fall. So not too hard, not too bad. We'll look at some more examples. So I know this graph doesn't appear as, not as easy to see as the other one. But same idea. Take a moment, just like what we did on that last one. See if you can come up with what is the domain of this graph and what is the range of this graph. What are your x values that can possibly reach? What are your y values that can possibly reach? So just take a quick moment. All right. What do we find for our domain? Action.
The highest is 5 and the lowest is -6.
All right. So typically when we do domain and range, we start from the lowest and we go to the highest. So let's just switch those around. And we'll do -3 to 5. So the lowest value our x ever reaches on our function is -3. The highest x value we ever reach is 5 in this situation. What about our range? 0 is the lowest, and what do we go up to?
Just kidding.
11. Good. So we start at 0, and that's the lowest part of our function reaches. We go all the way to the highest, and that's 11. Do we have questions, or is there something that's confusing or anything like that? Are we doing okay with this? Basically, at the moment, yeah. We'll talk about a special way of writing them tomorrow, but at the moment, this is really.
So do we get a worksheet that we get to do it, and it just has a couple of these? Yeah, it's simple and.
We'll talk about that more tomorrow when we look at it. Right now, we're just going to look at some more examples. There is one other thing that we might run into, or that we want to talk about. So far we've just been dealing with the line segments. So it has a point A and a point B, and we've been looking at like the values from that. But that's not always the situation, because that's not the only type of thing we've dealt with. We've dealt with other types of functions and other types of graphs in the past as well. For example, we had our exponential function that we dealt with.
Are we analyzing?
So we can also find the domain and range of a function like this. The thing to think about, though, it doesn't show the end of the graph. With a function like this, we can keep going. So what would be the lowest possible x value we could get for this function? Do you think you could go -8, -9, -10?
Well, they always split everything in half, so it's infinite.
So we could go even all the way down to -1 billion, -1 trillion. So there's no bottom end to the x values of this function. It can keep going and going and going and going. So we're going to say -infinity is the lowest possible x value. So there's no end to it. It can keep going and going and going in the. What's the largest possible x value you can reach in this function?
Infinite plus infinite.
It can keep going in this way as well. We can go 4, we can go 5. We're just restricted by the view of our graph. I can't have an infinite graph on this board. That would be pretty cool if I could. But because of that, we're restricted to the view that we only see this much. But it really keeps going and going and going and going. Yes.
An infinite graph is possible. It does have to be infinitely impossible.
It is impossible. Okay. So from -infinity to infinity, that encompasses any number. You can go as far as you want in the negative, as far as you want in the positive. It doesn't matter. You can put any x value. We have another way of writing this, in case you don't want to write -infinity to infinity. We call that real numbers, or we represent as all real numbers. And that's this funky looking R thing with sort of 2 lines. You may have seen this in the past when you talk about different types of numbers. So this represents all real numbers. It represents every single possible number from -infinity to positive infinity, all real numbers. So it looks like an R with 2 lines in it. So instead of writing this, if you wrote that, I would take it. That's correct. So that is our domain of our function. What's the range of our function? Action. Do we agree? -infinity to positive infinity?
If you ask if we agree, then it's probably he's wrong.
It could be right though.
Could be right. I agree on the right answer.
So we're going -infinity to positive infinity?
But it's not going to go under 0.
It never reaches below 0. If you remember when we learned about exponential functions,
Yeah.
they got very, very close to 0,
So
but they never actually passed
0, like 73 times 0 is 0.
So we're going to represent that as 0, even though it doesn't touch 0, it never actually equals 0. It gets very, 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 very close, infinitely close to 0. We're going to say 0 to infinity because it keeps going up and up and up and up and up, but it can never get lower than 0. It's just going to keep getting closer and closer to that. Right? And once again, tomorrow we're going to talk about special ways of writing this. So we'll have a special way of showing that it gets close to 0 but never actually touches it, and we'll have a special way of showing that it gets close to infinity, but you can never actually reach infinity because it's infinity and beyond.
You're not above like it's still there.
I'm beyond. So I know this one's a little bit different. Are we okay with the values we put for these numbers? Are we okay with how we determine them compared to the line segment? Okay. So we've seen these before towards the beginning of the year. We called these quadratic functions when it had that U shape.
I remember that.
Okay. So what do you think is the domain of this quadratic function?
-3 to, or wait, the domain is infinite, and then the range is -3 to infinity.
So because it has those arrows on it, it means it keeps going off our graph.
Make that
We can't see the end.
R thing.
So it's going to go from negative infinity to positive infinity, so we can call that all real numbers, or negative infinity to positive infinity. Either way you write it correct. So that's our domain. What's our range for our function? All real numbers again?
No, stop.
So the lowest point of our U, negative 3. So it goes from negative 3 up to
Infinity.
infinity. We can keep going up and up and up. We don't see an end to that, but the lowest point we ever reach. Okay. So the only time you can ever use the R is when you're going from negative infinity to positive infinity. So if you're just going one way to infinity, you'll just use that. Okay. Any other questions on this one? Doing okay in there? No? Yes? No? Okay. This is a funky graph. I know it's kind of hard to see. I'll highlight it for you. Start down here, and we go up, and we do a couple little bounces, and then we come down. I know it's a little bit hard to see probably for those in the back. But same idea. Take a moment by yourself. What's your domain? What's your range of the function? Take a moment and think about it. Okay, domain and range. What do we find for the domain of our function?
Domain was infinity. 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 To infinity.
So this is negative infinity to positive infinity. Even though it looks like even though it's going down very, very steep, it looks like it's not progressing any farther. It really still has a slope there. It's still going out. It just takes a very, very long time to keep going farther out. It's just moving. It's very, very steep in a sense, and that goes with both ways. So technically, it is negative infinity to positive infinity, or all real numbers if you wrote it like that. Both of those are. What about our range for our function? What do we find for that? Well,
The range is full and negative infinity.
so which one would we write first? Or negative infinity?
The lowest one.
The lowest one. So negative infinity is the lowest possible value we can reach, and then 4 would be the largest. Okay. Still doing okay on this? Think it's okay, easy enough? Is there anything that's confusing or that we feel is like the trickiest part about it at the moment? Okay. Making sure. Yeah, good question. All right.
Ooh.
So this isn't technically a function.
We're in geometry.
It's not technically a function, but we can still find the domain and range of it.
Geometry. Negative 5 to positive 5 and negative 5 to positive 5.
All right. Domain and range. Give me the domain of this circle. Actually,
5. 5 to 5 to negative 5 to 5. Letters.
negative 5 to 5. And then our range of our circle. What's our range?
Negative 5 to 5.
All right. Quick review. This isn't necessarily something we have to worry about for this week, but it's still something that we talked about in the past. Why is this not a function? Why is it not a
Because
function?
technically it has no beginning and no end. It's a circle. It's infinity.
Not quite. So we had a way to determine whether a graph was a function or not that we talked about earlier in the year.
I don't know. Not linear.
Why?
It's the parallel line test.
Vertical line test.
Vertical line.
So if you draw a vertical line, that's not vertical.
Oh yeah. Okay. Close enough. We forget.
If you draw a vertical line and you put it on that graph, and at some point it touches 2 points on your graph, it is not a
I
function.
remember that.
So this is not a function. You can still determine the domain and range of it, just like what we did. So it doesn't have to be a function to determine the domain and range, but that's typically what we use this for. So most of the time we're dealing with functions, but every now and then you might not get a function in there. And that's okay, you can still do it just the same way like we've done before. It's just something, just to keep in the back of your mind, if that ever shows up on your state test, remember you have your vertical line test here on. That's where we're going to pause it for today. I know we're a little bit ahead, or a little bit early, but we're going to keep working with domain and range for tomorrow. We're going to talk about how to write it specifically, and then we'll do a little bit of practice on just giving some examples to work on. Any questions from